Imagine a force so strong that it can destroy buildings, roads, power lines, or even toss boats around like toys. The force of nature that I'm actually referring to is called a hurricane. And that can cause that amount of destruction and devastation. My name is Donald Seymour, and I'm a Unified Public Safety Administration major at Northwestern State University. I've worked in EMS for 19 years, and I've actually responded to multiple hurricanes that have affected the Louisiana coast, most recently being Hurricanes Katrina, Rita, Gustav, and Ike. In preparation for this presentation, I went out to the libraries and also researched some websites to find out what actually causes hurricanes to form. Today, I will talk to you about what are hurricanes, what causes them to form, and what actually causes them to die or dissipate. So with these ideas in mind, let's get started. So what are hurricanes? According to the book Hurricanes, written by Joe Thorne in 2007, a hurricane is an intense group of thunderstorms arranged in a spiral band around a calm center that we call an eye. Some of the characteristics of a hurricane are as follows. In order for a storm to be considered a hurricane, the winds have to be at least 74 miles per hour sustained. Some of the strongest hurricanes have winds in excess of 155 miles per hour. The winds of a hurricane actually rotate in a counterclockwise fashion, and the average size of a hurricane is 350 miles across, with some of the largest hurricanes being 900 miles across. With these characteristics in mind, it is easy to see why they are so destructive. But let's talk about what causes them to form. According to the book Hurricanes, and I want to point out that it's the same title as the previous source I mentioned, however it's written by a different author. This one is written by Gail Gibbons, and the title of the book Hurricanes is noted by an exclamation point after the title. According to Gail Gibbons' book Hurricanes, all hurricanes form over tropical waters, and the same source cites the following. Tropical waters must be at least 81 degrees Fahrenheit or above in order for a hurricane to form. The water rises rapidly into the atmosphere. The evaporating water turns into warm, moist air, which actually, as the warm, moist air, it actually turns into condensation, which forms clouds and then thunderstorms. As this process is taking place, warm, moist air rising upward creates a larger draft that actually sucks in more warm, moist air and causes more water to be evaporated from the ocean surface. The winds in the atmosphere must remain weak, and the upper level winds have to be weak because as the air rises up above the clouds in the atmosphere, it disperses outward. If you have weak upper level winds in the atmosphere, it allows for the storms to begin to rotate and to start to cluster around each other, and they'll start rotating in a counterclockwise fashion. When this occurs, the wind speeds increase, the cycle increases, or the cycle continues, I should say, and when the winds finally reach 74 miles per hour sustained, it is actually called a hurricane. This graph right here, or this picture rather, actually depicts what I was just describing. As you can see from left to right and on the screen, you have westerly winds flowing in over warm tropical waters. You have easterly winds flowing from thunderstorms that's heading easterly. When the waters are over 81 degrees Fahrenheit and these two air masses collide, it can cause an uprise, cause the water to be evaporated and uprise into the atmosphere. Again stating that if the upper level winds in the atmosphere are relatively calm, the system meets no resistance. Thunderstorms form and it starts rotating in a counterclockwise fashion. According to the website weather.com, hosted by the Weather Channel, another way to think of a hurricane is as a large heat engine. The fuel of a hurricane would be the actual moisture of the warm ocean water. Moisture converts basically to heat into the thunderstorms, and the thunderstorms form. Air rises rapidly through the center, which condenses into clouds and rain. the condensation releases tremendous amount of heat into the atmosphere. As long as there are weak upper level winds, basically the system continues to repeat this cycle, and the engine actually refuels itself. Now that we know some of the characteristics of a hurricane and how they are formed, let's talk about what causes them to die or dissipate. So how hurricanes die? I previously mentioned that hurricanes, in order for a hurricane to form, they need warm tropical waters over 81 degrees Fahrenheit. And they must have weak upper level winds in the atmosphere. Well, simply, if we take all of these ingredients away, the hurricanes will basically lose their strength, or they will die. If water temperatures are cooler than 81 degrees, the hurricane will lose strength. It won't have that strength. The water will not evaporate. Basically, it will dissipate. Without the warm air refueling that heat engine, thunderstorms can't form. Winds in the atmosphere, if they are strong, it will prohibit the rotation of the storms in a counterclockwise fashion, and basically all of the ingredients are not there for the hurricane to form. Finally, if a hurricane is actually formed, when it makes landfall, all the sources needed for that heat engine, for that refueling over water, those sources are not present, and the storm actually dissipates, leaving in its wake a massive amount of destruction. As previously mentioned, hurricanes are a force of nature that can cause a lot of destruction. But in order for them to form, a few key ingredients still must be present. In summary, hurricanes are violent thunderstorms with winds that rotate in a counterclockwise fashion. The winds, in order for a storm to be classified and considered to be a hurricane, the winds must be at least 74 miles per hour, and they can be they can actually have winds over 155 miles per hour. The ingredients for a hurricane to form are warm tropical waters over 81 degrees Fahrenheit, light upper level winds, and remember, light westerly winds colliding with light easterly winds, which actually causes the evaporation of water to rise into the atmosphere. Finally, when the hurricane makes landfall, it dissipates. The ingredients are no longer there to fuel and refuel the system. Or when the system is actually over water and the water is actually cool, then there's no more energy left to fuel the hurricane or the storm. And this is a list of my